Before going on to the video, let me introduce myself to you real quick. Hello, my name is Anshul. I'm an electrical engineer. I like to explore and learn new things. YouTube is the new thing that I'm exploring and learning these days. Apart from this, I like gaming, reading books. Currently, I'm studying and preparing for engineering service examinations, so you guys can expect video of any of these above mentioned things. With no further ado, let's just jump onto the topic.
Ever since the day that you went away, you've been sending flowers to me, flowers today, flowers today.
Welcome to the control system, lecture 1. Before we learn what is a control system, I would like to ask to you, what is a system? Give it a thought. Okay. Simple saying, system, it is a means of transforming a signal. It is a means of transforming or changing a signal. So what is a signal? Signal is a function of one or more independent variables. We represent it with f of t, which is a function of time. This is the simplest block diagram of a system. Here x of t is input and y of t is an output. Y of t is nothing but transformed x of t. That is what system does. Now that you know what a system and the signal is, now it makes sense to you to know what a control system is. Control system, it is a system which produces desired output for a given input. Desired is the highlighted word here. That is, output of a system can be controlled by user in control system. Control system is that means by which any quantity of interest is maintained or altered according to a desired manner. Thus, we can also say that for a system to be a system, it has to be two or more number of signals. But for a system to be a control system, it needs to have two or more number of systems. I'm repeating it again. For a system to be a system, it has to be a two or more number of signals. For a system to be a control system, it needs to have two or more number of systems. Let's simply consider system 1 and system 2. One system is need to be controlled, another system is through which we control. Together, they are control system. The system that is need to be controlled is plant or process. The system through which we control is controller. Thus, we can develop a basic block diagram of control system from the idea of this. This is the basic block diagram of a control system. Input to the controller is command, reference input, or desired output. Let's not confuse ourselves with how a desired output is on the input side of the controller. Let's understand it in this way. Desired output to the input is nothing but the output we want from the controller. In that way, input is given to the controller. Then accordingly, from controller, actuating value is given to the plant or process, and then we get the control output. To understand the block diagram properly, take an example of fan and regulator. The speed at which we want the regulator is adjusted accordingly, that is, reference input or desired output or command. Then from regulator, current, that is signal according to set desired output, flows. It's nothing but actuating value. Then that current is given to the fan, that is the plant or process, and the speed of fan is according to it, that is, it is a controlled output. Therefore, the speed that we want is nothing but desired output, reference input, or command. What controller is the regulator here. Current is the actuating value, and fan itself is a plant or process. And the speed of fan, which is desired by us at which it to rotate, is nothing but controlled output. Now, this is all under ideal conditions. Ideal conditions, it is like a dreamy world in which we want to live. But practically, there are always some things that we don't really want. Okay. Coming back onto the topic. Practically, there will be disturbances on different parts of the systems. Usually, disturbances on plant or process will affect the most. Therefore, for this and because of this, the output is not exactly the desired one. Some errors can be present. To avoid this, either we can remove the disturbances or make the changes in actuating value according to disturbances such that output we get is nearest to the desired value. Here shown block diagram is the block diagram of a practical control system. The objective of any control system is to ensure that the controlled output becomes same as the command or desired output. This state of system is known as steady state. But if any disturbances occur, then the control output differs from set value. To restore the output to its original value, control system is modified as shown here. Error detector with the help of sensor produces error signal which the difference between desired output and actual output, which is suppressed by the controller. Hence, the effect of disturbance is removed from control system. It is used to identify the disturbances offered by the plant, not of itself or own disturbances. A control system can reach to steady state with 100% output only at t is equal to infinity. That is never. Because control system is designed such that disturbance effect associated with the plant is eliminated, but disturbances associated with other parts may still be present. Feedback in control system is employed mainly to improve its accuracy, but it also affects other characteristics of system like gain, bandwidth, speed, stability, sensitivity, etc. A feedback can be positive feedback signal or negative feedback signal. As we know, negative feedback signal is nothing but out of phase quantity, or it is just 180 degrees shifted. Negative feedback ensures better stability of the system, but simply only negative feedback won't make the system completely stable. So, this system with feedback that we have just discussed is nothing but closed loop control system or feedback control system. Now, the types of control system are: first, control system with feedback or open loop without feedback. In the next video, we will be learning the types of control system and all the important points related to it. Thank you.